Right. Hi, everyone. And today I'm going to talk about DeFi SDK and how it helps money lagers work together. So first of all, in the beginning, I'm going to give a short presentation and just talk about DeFi SDK, about the problem it solves, etc. And then in the end, since this session is technically called a workshop, I'm just going to share some pieces of code and just like do some hands-on to just like demonstrate the abilities of like things that you can do with DeFi SDK. So let's get started. So first of all, I just want to talk about the problem in general for a little bit. So DeFi in theory is designed to be interoperable, programmable, and composable. And there are multiple financial primitives that are built on top of each other, and there are new financial instruments appearing every day. And sometimes like there are even multiple appearing every day. And all of them are programmable, all of them are controlled by smart contracts, and all of them are supposedly composable, meaning that you can, since it's all on chain, since it's all on top of Ethereum, and right now I'm talking specifically about DeFi built on top of Ethereum primitives, it can be all combined together, and then you can create more complex financial instruments and derivatives on top of the existing ones. But in reality, things are not this great because the space is really fragmented and all the protocols are following different standards. In fact, there's no single standard in the space. That's why it becomes a nightmare for interfaces specifically once they want to display all the portfolios and all the balances all across DeFi. And especially it gets even worse when you try to track historical performance, again, for the same reasons. But even if you just want to show a simple balance of a wallet, it becomes an almost impossible challenge for most of the interfaces. And here's an interesting example. So this is a screenshot of exactly the same portfolio taken from 3 different mobile wallets. So first is MetaMask, the second one is Zerion, the third one is something else. I think it's probably Zapper. Anyways, so the idea is that it's super hard for interfaces and for wallets to integrate all the protocols and to stay on top of the market because they appear much faster. And players like Zapper or Zerion, they're trying to race to integrate all of the new protocols as soon as possible, but even them are falling behind a little bit. But for more standard wallets like Argent or MetaMask, it's almost impossible to stay on top of the market. And because, again, it's just like they have other problems to solve, and it's super hard to keep track of all what's going on in DeFi. And I think the great example why all the tokens are supported pretty much everywhere is because of the ERC20 standard that most of you probably heard of. It's a unified interface and most of the tokens try to implement it. And once we have multiple contracts, multiple tokens doing completely different things, but all of them supporting exactly the same interface, it's way easier for interfaces to work with them. But while there's no such standard in DeFi, it is a nightmare to try to integrate DeFi in your products and interfaces. So what is DeFi SDK? At Zerion, we struggled a lot with the problem that I just described above, and we tried to find a solution by creating a unified interface to all the protocols. So we designed DeFi SDK in a way that we deploy adapter to all the protocols, and then we try to unify interactions with all the possible protocols within like a single interface accessible externally. The great thing about that is that it can be accessed both externally and internally. What I mean by that is that it can either be used by other smart contracts on chain directly, or it can also be called off-chain and used to show different balances. For example, on this screenshot, we show the 3 adapters deployed for Aave, pulled together, and Curve protocols, and then DeFi SDK allows in a single call to receive all the balances deposited, all the address balances deposited to all the 3 protocols. One of the main features that it allows the developers and interfaces do is to actually make sense of complex DeFi derivative and assets. As I mentioned in the very beginning, lots of financial instruments in DeFi consist of some underlying assets. And here I look at an example of a compound DAI Uniswap liquidity pool, meaning that is a token that represents a share of a Uniswap pool that consists of Ether and CDAI. And at the same time, CDAI itself consists of DAI, and there are different exchange rates between all of the assets in this chain. And in the end, we still want to understand the actual price of the LP token that we have at the very left. And DeFi SDK can easily help with that problem, assuming that we somehow know the prices of the most base layer tokens, such as Ethereum and DAI in this example. And I believe these days in 2020, it's not a big problem anymore. There are lots of open and public APIs, for example, CoinGecko, who solve this problem pretty well. So it's fairly easy to find the price for Ether and DAI, but it is way more complicated and almost impossible to determine the price of one Uniswap LP token unless you use DeFi SDK for that matter. And another problem comes when you not only try to understand what's going on there and what the values of different tokens are, but when you actually want to interact with different protocols, because again, if you want to build some product on top of already existing protocols, you will probably like to interact with them in any way. And that means that you will need to go to different documentations, explore all the variety of the smart contracts, figure out how that specific contract that you want to interact with works, since there is no single interface again, then just becomes lots of pain. And moreover, smart contracts upgrade sometimes, they can change their interfaces, and it's really hard to keep track of all of that. What we thought when we designed DeFi SDK is actually most of the protocol interactions can be described as simple deposit and withdraw actions, pretty much for any protocol out there, whether it's like Uniswap liquidity pool, whether it's compound deposits, whether it's something else. Most of the things you can do with the protocol is either to deposit some money or assets in that protocol or withdraw them back if you already have some assets locked in there. The same applies to multiple staking protocols. So for example, there's like Loopring staking protocol that allows you to stake your Loopring and then withdraw it back. But again, it's all can be described, or like almost everything can be described as a simple deposit and withdraw functions. So that is exactly the interface that DeFi SDK provides via adapters. And then we can take a look at an example of how we can purchase the ETH DAI Uniswap LP pool shares, assuming that we already have CDAI in our account and we want to make that complex transaction. Without DeFi SDK, it would require lots of separate transactions because first we will need to go to Compound to unwrap our CDAI back to DAI. Then we will need to find the best exchange rate to exchange half of our DAI into Ether. And then once we have half of our assets in DAI and half of our assets in Ether, we can use them to go to Uniswap interface and deposit them into Uniswap pool. However, all of that can be easily done via DeFi SDK in a single transaction, just mixing and matching the actions of withdrawals and deposits. And as the chart shows here, we can just like use the withdraw DAI action from Compound, then deposit half of it into Kyber, withdraw Ether, meaning like we use Kyber to exchange DAI into Ether, and then deposit all of the assets into Uniswap to get the LP shares. So pretty much just sum up everything that I said above. The benefits of DeFi SDK for interfaces, for developers, for wallets, is that it is a single API to create any sort of DeFi transactions with any kinds of DeFi protocols, as long as we have an adapter written. And moreover, we encourage protocol developers to update their adapters so that even if there's any change in the protocol itself, most likely our adapter is going to be updated as well, which means that there's no need to update anything on the client side. And at the same time, once new adapters are added, pretty much all of the integrations with DeFi SDK get exposure to all those new protocols integrated in DeFi SDK. again, with a zero development cost on their side. And at the same time, it is possible to use the same set of smart contracts on chain, which means that you can create any kind of complex transactions to interact between different DeFi protocols. Think about some arbitrage opportunities, for instance, where you can, in a single transaction, buy some asset from Uniswap, withdraw it, exchange it, like let's say on Curve, and then take the profit. And all of that you can do on chain without the need to deploy your own contracts, but just mixing and matching deposit and withdrawal actions available as part of the DeFi SDK. And the last great thing, it allows you to query users' balances across all the DeFi protocols. Again, it's a single call function that allows you to know what particular address deposited or staked or did whatever all across DeFi. And it is, again, unified interaction with protocols, and it's free to use. And it's all available on GitHub. It is open source, so you can easily verify all the source codes, and also the contracts on Etherscan are available as well. And at the same time, we have multiple wrappers around DeFi SDK contracts written in different programming languages. So for example, we have DeFi SDK in Python, which pretty much means that you can install a library using pip, and then you can just like interact with DeFi SDK off-chain from your Python app fairly easily and straightforwardly. That is actually what I'm going to demonstrate right now. Just gonna do like some hands-on here in a bit. All right, so here we go. So here, as I said, I'm gonna use the DeFi SDK package, and I have it installed. So it's just like simple pip install DeFi SDK. And to get started, all you need to provide is the Ethereum node URL. So I'm just going to use the info URL with my key. And here, first, I can see what protocols DeFi SDK support at the moment. So here's the list of human readable protocols. So every call that I make here is actually proxied to Infura. So it's all on chain, nothing is stored locally. And here we can see that as of now, I can see and interact with protocols like Nexus Mutual, SushiSwap, Ample First, DDEX, Token Sets, etc. And at the same time, I can also see what kind of tokens DeFi SDK can understand, meaning that if I'm gonna ask DeFi SDK of what that token consists of, it's gonna tell me its type and the underlying assets. And that is actually the first example that I would like to show here. So I believe most of you have heard of DeFi Pulse Index that they launched recently using Token Sets protocol. And that is pretty much a derivative asset that consists of many underlying DeFi assets under the hood. And pretty much by buying that DPI token, you get exposure to DeFi. So let's try to use DeFi SDK to make sense of what exactly DeFi Pulse Index token is. So here I have its address, and I already know that its type is set token V2 because it's created as a set token. And here I can see that DeFi SDK supports set tokens, which means that it's going to help me to understand what it looks like. So here I'm going to do this call to get token components. And the answer is that it contains all of these underlying assets with these proportions. So pretty much I can see now that DPI token contains whatever 10 different DeFi assets and the value of each underlying asset in one DPI token. And let's move a little further. And for example, I want to know what it's worth as of now. And ideally, I would like to use some off-chain price source, but since I wanted to keep this example on-chain only, I hard-coded the addresses of Uniswap pools for all the underlying assets that the DPI asset has. So pretty much right now, I'm just going to use DeFi SDK to calculate the price of each of the underlying asset based on the appropriate Uniswap pool token, knowing that Uniswap pools are created in such a way that the underlying value of Ether is equal to the underlying value of the other token. So here I'm going to quickly run this code to get the price in Ether of each underlying token of the DPI. And let's see what we get here. So yeah, there we go. Just using DeFi SDK, again, like no off-chain sources, we just got the prices of all the assets here using Uniswap pools as the price source. And just a quick note here, I wouldn't recommend doing that in production because I assume most of you know that Uniswap pools can be easily manipulated because like the liquidity can be low, etc. So it's not a good way to use them as a price source, but I think it's good enough for this example. So now let's try to find out the actual price of the DPI token by multiplying its component balances that we received earlier by the price that we just received. And here we can see that one DPI is approximately equal to 0.16 Ether, or I believe Ether is around, not sure what the recent price is, but let's call it 380. So let's call it $60 per one DPI token, which I believe is pretty accurate. You can double check it on CoinGecko or somewhere else. And here, for example, we can also plot the distribution of the underlying assets of DPI based on the data that we just obtained. And now we can just see this nice pie chart showing the value of each underlying token inside one DPI. So that pretty much means that once you buy one DPI, you get exposure to all of these assets. So that was my first example. And the second example, as I mentioned on my slides, is actually within a single call, we can easily understand and find the balances of a user address all across different DeFi protocols. So here I'm just going to use my test address, and I'm going to query DeFi SDK to see where I have all my balances. And yeah, here we go. So it just returns as an answer that I have some wire and finance vaults, that I have some DAI deposited into the DEX, and I have a tiny bit of synthetics that I probably forgot to withdraw. And I also have some deposits on DYDX compound and Aave. And now I can use DeFi SDK to also easily do something with those balances. So for example, here I can see that it's just again the same data, just like different view, that I have 48.6 compound USDC coins deposited in compound. And here I can just quickly show that by using DeFi SDK, we can easily withdraw those amounts using just the withdraw function. So pretty much for any interaction with DeFi SDK, every call consists of three lists of parameters. First thing is inputs. So those are the tokens that I want to use as my inputs. So in this example, I'm just going to withdraw my CUSDC tokens, and I have this many of them, and here's my input. And then I need to describe the list of actions that I want to do with them. So I'm saying that I want to withdraw them from compound, and the adapter type asset just means that it is my deposit. It could be a debt, for instances. And here I just say how much I want to withdraw. And the mean outputs parameter is my expectation from DeFi SDK, pretty much saying that I expect to receive at least, well, 0 is like a little bit too pessimistic. I can say here that I expect to receive at least 10 and 1, 2, 3, 1, 2, 3 decimals, meaning that as the result of this transaction of withdrawing CUSDC token from compound, I expect to receive at least 10 USDC tokens back. Otherwise, the transaction is going to fail. And here I just do the call to DeFi SDK. And as the result, it's going to tell me that my expectation is actually too high, and I'm not going to receive 10 USDC tokens back. So I'll just set it to 0. And now it says that this is actually how many USDC tokens I'm going to receive back as the result of this transaction. And then fairly easily, I can execute it in the end. And of course, for this particular case, it's not very interesting to use DeFi SDK because we could have easily gone to Compound and do the same. But what is cool about this example is that, as you can see, it is a list of actions. So we can mix and match them together in any way and create pretty much our own financial transactions of any complexity, just program them very simply and then send to Ethereum without the need to try to write any new contracts, for instance. So if you have any use case that you want to implement, for example, as I mentioned earlier, you see some arbitrage opportunity where you can like buy tokens from one protocol, sell on the other one, you can just fairly easily describe it in this simple language of the DeFi SDK and then execute the transaction and pretty much make money from the transaction without any additional costs. So that was it from the hands-on experience. I'm just gonna go and switch back to my slides. And again, here's the QR code where you can scan it and find the link to the source code of the DeFi SDK smart contracts on GitHub. And I also encourage you to join us on our Discord, where we have like our community. And if you have any questions, feel free to just drop a message there and like inquire anything about DeFi SDK. And me personally and our developers will be happy to help you with that. And I think that's all from my side. Thanks for your time. Thanks for listening.